So back from virtual reality to real reality, I'd like to ask Mr. Gauthier Humbert. Now he's talking with the Bixi hat. Yeah, all right, thank you.
Great. Hello again. So, this time you get to see some of the same slides, some different ones. My hat is different. Now I'm here to present some of the Bixi solutions and what we're about. Once again, there's standards out there. I won't explain all the details again, but there's the IEEE for the applications, there's the ISO for international, there's the CENELEC for European, which I didn't show before. So CENELEC is almost identical to ISO with some minor differences. There's the TIA for the North American. And then there's Bixi. So where do we fit in? Bixi, we have publications. We write books. So we have the TDMM. Who's read the TDMM here? Not many. So that's how to get certified Bixi, basically. We also have standards. So TDMM is here, outside plant, auto cable outside plant. And then we have all this range of standards, which, well, where do they fit in? Since we already have the ISO, CENELEC, TIA, why is there another Bixi standard? So I'll take a few examples to clarify this. So Bixi developed standards in ICT, so digital infrastructure. Our standards are written by volunteers. There's about 500 worldwide. They're all neutral. And this is a non-profit program. So Bixi is not here to make profit from the standards. It's just there to write them and provide them to the community. People then purchase a book, and that's it. They don't pay any extra fees. And what it's about, it's best practice. So when you start a project, you first have the regulations. That's the mandatory part. Then you start to look into these other standards, and you might follow some ASHRAE recommendations for the temperature and humidity, NFPA in the US for the fire rating, different ones in Europe. And then you'll choose to follow either ISO or CENELEC or TIA for the cabling. All of those are minimum requirements. They tell you if you don't do it this way, you're not guaranteed it will work. Bixi is telling you how to make everything fit together. It's giving you the bigger vision of all of this and explaining how it works. Example with the star topology in cabling, everybody knows this. Floor distributor, building distributor, campus distributor, it's always been the case. It's explained to you also the horizontal channel, 90-meter permanent link, 100-meter channel, up to 4 connectors, etc. Now, our world is changing, our standards are changing. Who installs wireless access points here? One more of you? Okay. How do we install it? Well, typically, we do a site survey. We study the site, and if we have the right equipment, we're actually going to analyze where to put the access points so we have the best performance possible with the fewest access points possible, or more if the customer wants it. That's great. And then we bring the cables. So we put one access point right there, and we brought one cable right there. What happens in the future? what if we need another access point? Well, we bring another cable. Oh, what if you want to move the access point? Oh, you have to redo the cabling. That's not structured cabling. Structured cabling is about ensuring that your infrastructure is ready for the future. And all you do in the future is move patch cords, not cables. So that method that we've been doing for so long is not sufficient. We should not be cabling the Wi-Fi access points afterwards. We should first provide an infrastructure, then define the access points. It's logical. Well, guess what? The standards took it into account. So now, there is standards in TIA and in ISO about how to do cabling ready for wireless access points. That's not about how to position your access points. And it's telling you need minimum 2 ports, okay? And it's an access point service outlet, and it's Cat6a minimum. Why? Because of the performance. 10 gig, basically. If you follow TIA, you're going to have a square grid. If you follow ISO, you're going to have the honeycomb design. Both of them are about the same belief, that you position a connecting box somewhere, put them in a pattern around the false ceiling. Afterwards, you do your site survey, and then you connect your access points with patch cords. So if in the future you move an access point or you add one, it's ready for it. You do not need to re-cable anything in the ceiling. Great. Well, BIG-C also has a Wi-Fi standard. It's called the BIG-C 08, 008. And you're going to find, guess what? Regulatory and safety, like I started before. What are the regulations in each country? Which access point frequencies are you allowed to use? Can you use that channel 14? Not everywhere. It's going to explain to you how the wireless systems function, how to do that site survey. It's giving you some assistance on this. And it's going to tell you how to do the cabling infrastructure. And you recognize those diagrams? Yes, those are from TIA and ISO. So it's complementary to TIA and ISO. But it's not limited to that scope of work. It's giving you the bigger picture. Afterwards, it's going to say how to test it. So how to do that test of the modified permanent link, or which is now, yeah. And then the site considerations, what you need to look at, what issues you might have. So when you are deploying Wi-Fi access point, you can say, I'm going to take the ISO or the TIA standard to be compliant for my cabling, but I'm going to take the BIG-C standard for the complete installation to help me on how to do things in the proper way. Then there's another standard. Our world keeps changing. Everybody's talking about IoT today, right? That's the next big trend. Actually, it started today already. There's a standard called the 11801-6, Distributed Building Services. And now it's telling us you can design it differently from the past. Campus, building distributor, floor distributor, which is now called SD, service distribution, and a service consolidation point, or SCP. Well, from there on, you're going to cable application specific. So it's telling you, you can bring now your structured cabling, your 4-pair cables, all the way to here using the traditional method, and from here on, you're allowed to do it differently. What's differently? Well, it means connecting your camera directly on the cable with a plug. It's explaining how to do this. Before it didn't. It's explaining that you can now put bus, star, or tree and branch topology behind this. That's new. There's an equivalent in TIA, which is the 562B, which says basically the same thing using different terms. And what about BIG-C? Well, we have the 007. And what that document is going to say is, what is your service outlets? What is it for? What can you connect to it? The standards didn't say. They said you can have them. The BIG-C standard is going to say what they are for. So how should you design your building in order to be ready for this? So it's showing you that these are not telecom outlets. their service for these other devices. It's telling you how to cable it. This is compliant to the other ones you saw, but now it's explaining all your variations. What is the HCP? That's TIA or SCP and ISO. Well, does it have to be a wall-mounted cabinet? No, it doesn't. It can be something in the ceiling, for example. Here's a picture. How to position them. Oh, nice diagrams. We recognize those, right? So it's basically telling you that to do intelligent building, you're going to make an infrastructure which is similar for the Wi-Fi and for the IoT. You're going to have the same base up to a certain point, and then you're going to split. And it's going to explain to you how to use PoE. Well, what do I need PoE for? Oh, here's something. Here's the old lighting control management system, all on 220 volts. But somebody invented LEDs, and LEDs consume a lot less energy than the old light bulbs. So we don't need as much power. Aha. So why are we still bringing the same electrical cables in the lighting when we don't need them? Our electrical cables are 220 volts, 10 amps. But we're putting 5 watts on them. That's kind of stupid. So this is now explaining to us, well, why don't you use PoE for your lighting? Ah, smart idea. This exists today, huh? There are projects that have now gotten rid of all of the electrical cabling in the ceiling. Everything up there is based on structured cabling. Lighting is PoE. The curtains, electrical curtains are PoE. HVAC, the control of it is PoE. So it's going to tell us, well, just put your lighting on PoE systems just like this. There's many advantages to this. Some of them is getting rid of that 220 volts. Some of it is for future changes. When you need to move one light from here to here, you have to call an electrician. Imagine this was structured cabling. You just take a patch cord and move it, finished. Done instantly. A lot of advantages to this. So here, Bixby is going to explain to us how to set this up. And again, what other systems are there? Remember, those standards, cabling standards, didn't tell us exactly all the systems. Bixby is going to go into each of the systems and tell us what is different in the design, how we should look at it. So structured cabling evolves. That's my last slide. This is how it used to be a long time ago. I hope nobody has this anymore at home or in the office. Maybe the telecoms still have something like this laying around. Our world is changing. Our digital infrastructure, or ICT infrastructure, is becoming a digital infrastructure. Now we want the refrigerator to connect to our network. We want everything connected on the same IT network. The standards, the cabling standards, the national standards, they will continue to evolve and provide us with the minimum requirements. The Bixby standards will continue to exist to explain to us how to implement all of this. Just as a reminder, that's basically the diagram that we show, is that we have the government regulations, then we have the codes, all of these are mandatory, then we have all of the standards where you choose which ones you want to follow, and Bixby covers everything, just explaining how it fits together. That's the end of my presentation here. Thank you for your attention.